Speaker is Andrew Mergenmeier. Thank you. He's a senior pavement and materials engineer for FHWA. He's responsible for the high friction management program. Mr. Andy.
Thank you, Arnett. I appreciate it. I'm with Federal Highway Administration. I'm in the Pavement and Materials Resource Center. So Luis and I, we are on the same team. We're not located in the same city. We're broken up generally by specific areas within the pavement arena. For about the past 10 years, most of my time has been focused in pavement surface characterization, things like rutting, cracking, and friction. And today I'll be talking about high friction surface treatments. And because this is the Pavement Preservation Partnership, it is entitled High Friction Surface Treatments, Preservation or Not. One thing I was hoping is, I really thought that, Arnett, whenever you started this meeting, because this is a Pavement Preservation Partnership, before this group, it was what, the Southeast Pavement Management System group, right? That was a general group that met about every year, and I'd gone to that, but this is my first Pavement Preservation Partnership meeting. And because you're a partnership, I really thought maybe you would start the meeting with some preamble. You all stand up and say, I pledge allegiance to the Pavement Preservation Partnership. And here's the definition on the website, so I just brought it forward so that I know that you all have this memorized, but I wanted to put it in front of you so that you have this in mind as we go through this presentation and figure out, is high friction surface treatment a preservation treatment or not? I looked at this definition and thought it had a couple good things in it, talking about long-term strategies, and also it's enhancing pavement performance, and it includes such things as extending pavement life, improving safety, which I think is very interesting, and meeting motorist expectations. So the three things that I got out of it is pavement life, safety, and motorist expectations, things that a lot of us traditional pavement engineers don't really think about. Whenever we think of preservation, we're really thinking of the hardcore stuff, keeping the structural integrity there, trying to reduce areas that are starting to decay and make it last longer. Okay, so that's preservation. So what is high friction surface treatments? Well, I'll tell you what high friction surface treatments do. They save lives. It's very clear that in locations that have a very high friction demand, that if you place this very high friction course, that you reduce crashes and save lives. And it is at a higher level. That's one thing I want to emphasize is a high friction surface treatment isn't as things we think about preservation is kind of bringing it back to what it was originally. A high friction surface treatment is not about that. It's taking friction to a level that existing pavement has not had. And you put it in locations where you need this greater friction. And if you think about it, you're driving down a tangent section of interstate, you're really not moving around, it's high speed in a rural area. Your friction demand is not very high. But then you go to a ramp, a horizontal curve that all of a sudden you're hitting 65 and then it goes down to 45. Through an intersection, your vehicle, you got to start to brake. You have some movements left to right. You know, it's pretty clear that you need more friction at that location. So as you go down the road, the friction demand varies throughout that section. And so that's really an appreciation that not every section requires the same amount of friction, and that in general, the pavement friction provided by most of our pavements meet that friction demand. But there are certain spot locations, and high friction surface treatments are about spot locations. It is fairly costly. We want to target those spot locations. Here's a good slide showing an existing facility. In 2008, this interchange was reconstructed in Marquette. This is new wearing course in 2008. And this video here is from 2011. And the video is over a course of 2 days in May. So you can see that there's a serious situation going on here, and it's very consistent. I don't know if you have any places like this in your state, but the great thing is with cameras, you know, it really provides us a lot of good information that we can make to make better decisions. And the other thing I want to highlight, I'm a pavements guy, but I've been working with safety for about the past 10 years. And one thing the safety folks say is, you know, our safety data is not very good. Now, us in pavements, we continue to say our pavement data is not very good. And if you look at this, think about how many of these crashes here are reported crashes. Because if you look at the crash data that our state DOTs have, it's reported crashes. So you can just start to imagine how many crashes actually get reported from what occur out there, and you start to think it is a fairly small subset. So good information here. And here are the number of crashes. Again, so think about it. This is reported crashes. And you can see this timeline starts from whenever that interchange was reconstructed up until the high friction surface treatment was applied in 2011, it looks like, and then the years afterwards. And you can see for this one location that this one treatment was very cost effective in reducing crashes. So this is just one location. You know, it is an anomaly. I don't know of other places that have this type of crash rate, but it's very clearly reality, a good application of high friction surface treatments. We didn't have to reconstruct the interchange or anything like that. Now let's go look at a state that is recognized nationally as having a very aggressive and mature high friction surface treatment program, Kentucky. They were gracious enough to host me in 2013 whenever I was really starting to get into high friction surface treatments. It was part of the Everyday Counts Phase 2 push from Federal Highway Administration. They taught me a great deal about high friction surface treatments because they really got into it early. It was great, and they are just great hosts. They really educated me on many Central Virginia local things that you need to know if you ever go there. Why is the water so important? The bourbon trails, the horses, the thoroughbreds, why are they so predominant in that area? Again, it goes back to the water. All I can say is those guys were great. They introduced me to a lot of good things, including high friction surface treatments. Also, it's Kentucky basketball. They got me tickets to a game that night. I just want to give them a shout out that they were a great host, and I learned a great deal. This information here, like I said, I was there in 2013. The data here is as of 2015. Every year they continue to update their analysis. And what you can see here is this is at 60 locations, and these 60 locations all had 3 years of crash data before high friction surface treatment was placed, and at least 3 years of after crash data. So this is not all of their locations, it's a subset of their locations of high friction. And so you can see the data analysis was in 2015, so all these locations were, if you go 3 years less of 2012, so they were around 2010, 2012 time frame, and think about the installations that you guys have put in, if you put in many that long ago. Okay, of the 60 locations, 48 of these were on horizontal curves, and so that put 12 locations were at ramps. And you can see very clearly the crash reductions. The interesting thing is I looked at my data from 2013, and if you look at the dry average crash reduction for curves, it was about 57% or something like that. So it was interesting to me to note that the crash reduction in dry conditions increased that much over the years. And because one thing that we talk about in friction, traditionally, we've been around in friction since the 50s and 60s. And the emphasis has been on wet pavement crashes. But Kentucky clearly shows you here that it's not just a wet pavement situation, it is also dry pavement. One thing I also want to highlight, all these locations had a crash history that gave them confidence that it was in a high friction demand area. So, these weren't just randomly picked horizontal curves that had certain advisory speed limits. They did have a crash history. They went out to every location and looked at it and thought, hey, is this potentially a friction issue? So again, this is a good example of where they did a lot of engineering and a very cost-effective application, and you can see very clearly their reductions. In 2008, AASHTO updated the guide for pavement friction, and this is a guide that essentially was based on historical information about friction, and it, again, emphasized the issue about wet weather, and plus they brought forward this concept about friction demand, just the recognition that we have different friction demand at different locations in the roadway, and we need to have solutions for that, and that these are generally many times in spot locations. All right, so what is high friction surface treatment? The definition of high friction surface treatment right now we have at Federal Highway Administration is highly dependent on the aggregate, and it is the calcined bauxite, which is a manufactured aggregate. That's the only aggregate that currently we believe meets the definition of high friction. We've tried many other types of aggregate, but the calcined bauxite provides an extremely high level of friction, and it maintains that high level over the life of the surface treatment versus other aggregates that have been tested, and we're continuing to test other aggregates, but they've decayed in their friction level. And then there are various types of binder that can be used. The predominant one that we've used in the United States is the epoxy. The other binders are generally applied whenever weather conditions for installation may not be most desirable, so they use a little bit different binder for those purposes because, again, you got to take into account cost. High friction started in the United States in the 1950s, and then in the 60s, the UK started to use it more, and it's been in their toolbox for many years. And then in the 2010 time frame, the US started to use high friction again, and with the Everyday Counts effort, Federal Highway encouraging states, the number of high friction installations have just, gone off the charts and been proven out very well. All right, so looking at the binder, there's many different ways of applying the binder, and here is an example of a couple of high production binder application techniques. The goal is that the binder will be about 50% of the thickness of the aggregate so that you have good embedment. My experience with high friction surface treatments is that calcined bauxite does not polish. Whenever the decay, the reduction in friction over time, what I've seen is it's from the loss of the aggregate from the binder. So it really isn't traditional polishing of the aggregate. My experience has been you've lost the aggregate, and so what you have left is the binder. But again, that's just been my experience. The calcined bauxite, it's a manufactured aggregate. It's from the refractory industry. Very fine aggregate, essentially single size, 1/8 inch. It comes in bags such as this. Again, it's not a high production amount of material, and it's packaged up. And so it's very transportable and can be brought anywhere across the country with regular transport. Quick raise of the hands. How many folks have been on site for a high friction surface installation? Okay, excellent. We've got, looks like a good 50%. For those who have not been out there, you can see the binders being applied. The man with the paint roller is smoothing out the binder application. Oh, it's not. Well,
maybe you won't take us there.
I guess I will not take you there. It worked on my slide, so let's go back. All right, so we'll skip that. Essentially, it's very similar to a chip seal operation, but you do not have rollers going on afterwards. Again, what I've seen as far as performance, it works well, but the key thing is like any construction operation. It's highly dependent upon weather. It's highly dependent upon your binder application. You should have an inspector out there to at least get them started going early on. Your binder's got to set up very quickly. If you don't have the right mix of the binder, it will not set up very well. So again, it's like any product out there. You got to pay attention, know what you're doing, otherwise you will not get the performance you're looking for. All right, here's a picture of the surface on your left-hand side. You'll see that that's conventional dense graded asphalt, and on the right-hand side is the high friction surface treatment. Again, a very thin lift. Whenever I've driven over it, compared to a dense graded mix, the high friction has, to me, a little bit quieter sound, a little bit more pleasing sound. You really don't notice it going over it. Many state DOT specifications require a locked wheel friction trailer to test the material, and many times it is a rib tire, and the locked wheel number needs to be a 65 or greater. I'm not aware of any state that has in the contract that 1 year later you have to go out and test with the friction. I think many folks do just to look at the decay and change over time, but many states have this initial friction requirement. Here's a slide showing you the use of high friction surface treatments. You can see in the southeast it is aggressively used in many locations. You can see where your state is. Again, it's definitely been used a lot in the U.S. over the past 7-8 years. Okay, Federal Highway Administration, trying to look, I've heard several folks talk about the toolbox. You need to have many different options in your pavement preservation toolbox so you can go out and treat the roads cost effectively for different applications. Federal Highway is funding a test section out at the NCAT test track, and it's to look at an enhanced friction microsurfacing. So again, I don't want to give the impression it's a high friction surface treatment. It is not. It's a little bit less, but still it's greater than a conventional microsurfacing. And the expectation is there are certain sections of road where maybe you would like to be able to do a microsurfacing that has very good friction characteristics and has some good crack sealing characteristics also. So this is currently ongoing at NCAT. And here's a picture of the microsurfacing surface. And essentially the key element of it is the coarse aggregate is 50% calcined bauxite. And the binder is a highly modified emulsion. So those are the main changes from your conventional microsurfacing. All right, let's look at some friction testing. This is from NCAT. On the vertical scale, you have a locked wheel skid trailer, the skid number, and on the horizontal axis, you have a time frame, and you'll see it September 2015 to June of 2016, so just recently. And I want to highlight the surfaces. If you look at the top 4, they were placed in 2015, and the bottom 3 were placed in 2011. And you'll see that the top line is the high friction surface treatment bauxite that was placed in 2011. So you can see here that it's maintained a good level of friction since 2011, and it's the best of all the sections as of to date. The next one is the higher friction microsurfacing with the bauxite. Again, it was only placed in 2015, so this is less than 1 year, and you can see the friction is maintained at a fairly good level. The next one is a higher friction microsurfacing with the sandstone. Again, it's decaying off with the friction to a certain degree. And then as you go down, you'll see different levels. And I just want to point out the lower 2 are higher friction SMAs, where they try to modify SMA granite to get a higher friction level than conventional SMA. And you can see that the decay is down around 30 after about a year. So good information on friction. NCAT is testing regularly, and they had a section of high friction out there. It's not shown on this graph. It's about 7 or 9 years old, and it again demonstrated that the high friction surface treatment with bauxite maintains its friction over time. All right, here's just an example of what could be a toolbox for pavement friction. You can see the second column says pavement preservation. That is the conventional way of you think of pavement preservation. Crack sealing, bringing back some life to the pavement surface from a longevity, durability standpoint. And that's why the epoxy high friction surface treatment has a not applicable in its box. And as you go across, you have application, again, spot treatment for the epoxy high friction surface treatment. You look at the cost estimates. Generally, this is the estimates that I've seen in the $20 to $30 range per square yard. Again, it all depends how your contract is set up. Many different factors in there. And again, that is the very highest friction that we have available to us currently. In the middle there, you have this concept that we're testing out at NCAT, which is the asphalt-based enhanced friction. So that's the microsurfacing with the bauxite, 50% in the coarse aggregate. And you can see, again, it's the concept that it could be a spot treatment or a little bit longer length down the road. And then the third one is a high friction thin lay. And what that is that's a 4.75 millimeter mix placed at about a 1/4 inch to a 1/2 inch in thickness. And again, that's replacing about half of the coarse aggregate with the bauxite material. Again, this is just still conceptual. It's being researched. But again, this concept of supplementing your conventional aggregate with a higher friction quality aggregate, that's been in place in many states. And the one that I can think of most readily is Florida. They do it all the time. They have a real issue with friction on their wearing courses. They place a very thin overlay to try to keep that cost down. And so they're looking at different ways of blending aggregates to get the friction that they need. So again, this is just an example of maybe what will occur in the future from a friction engineering toolbox. Okay, so what do we have today? This is a conventional high friction surface treatment mix. You can see the change in color where it's the dense graded asphalt on your left and then the high friction towards the middle. And look at that crack that's in the existing pavement. The crack comes back through. That's just high friction. It is not sealing up those cracks. It doesn't provide that level of preservation, traditional preservation. But again, think about what your definition of preservation is, and then think about, will the enhanced microsurfacing maybe add some additional preservation elements to it, bringing back some life to the pavement from a flexibility and friction tuning. Again, stay tuned with the NCAT test track, and that's all that I have at this time. Thank you.
Are there any questions?
Feng Hong, Texas DOT. I have a quick question. Does this high friction layer apply to all level of traffic, like low traffic as well as high traffic? Thank you.
The question is about high friction surface treatments and where it can be applied based on traffic, for example, the interstate primaries and secondary. The key thing about the high friction surface treatment, and you saw that crack, it comes right back through. So think about the pavement that you're putting it on. It needs to be in pretty good shape from a durability structural standpoint. If it has alligator cracking, guess what? You may not get the life out of the high friction surface treatment, but it's not because of the high friction, it's because of the underlying material. And so whenever I've queried various pavement engineers and various state DOTs, they'll use terms like the existing pavement needs to be in a fair to good condition from a durability standpoint. Again, you think about it, you're applying this expensive material on top, so you need to make sure the underlying is in good condition. Others have said that if the existing pavement is 4 years or less, then we don't have an issue putting it on. So that's one key element, is you got to look at that pavement. As far as applying it on any of them, yes, it has been successful in low traffic and in high traffic. It's been successful on interstate facilities at very high traffic. Again, that epoxy binder or the other types of binders are very durable, have very high tensile strength retention, but again, the key is you have to get that aggregate embedment at 50%. And the other thing is that we know that you need to go out and sweep that high friction surface treatment and put it in your contract. It's in the AASHTO spec. At least you want to wait you sweep it as soon as you're done and open to traffic, then you need to come back about 48 hours or 72 hours later, because you'll again have a little bit of aggregate loss. Shedding on the side, you need to make sure you come in and sweep it off the shoulder, because your shoulder's not getting the high friction, so essentially you've got that loose aggregate out there. It's kind of like ball bearings. You're on a motorcycle or something, you hit that, it's not a good situation. So in all your high friction contracts, make sure you put the requirement the contractor has to go out there and sweep it and clean those shoulders about 72 hours afterwards.
Thank you so much.